All right, so here in this section, we are going to discuss some shortcut rules regarding computing the derivative. And before we have been using the definition of the instantaneous rate of change by using the limit as h approaches 0 of f of x plus h minus f of x over h. And method is called using the difference quotient, but sometimes it could be cumbersome to go ahead and compute the derivative this way all the time. And sometimes it could be a little tedious watching our signs and that sort of thing. So we want to discuss some shortcut rules that are going to go ahead and help us make these calculations more efficient. And the first rule we want to discuss is the power rule. And this means if we have some function f of x is equal to x to the n, this means we could go ahead and according to our derivative, take our n, put it in the front of our function, and then subtract 1 from our exponent. All right, so let's look at a couple examples to kind of give you an idea of what this is all about. So if I have a function f of x is equal to x cubed, and I want to go ahead and take the derivative is going to go ahead, take this 3 that's in the exponent, pull it to the front, and then we're going to subtract 1 from the exponent. So in this case, the derivative of x cubed is going to be 3x squared. If we go ahead and look at another function of f of x is equal to x, now remember when we have just a variable by itself, it has an exponent of 1. And so when we go ahead and take the derivative of just f of x is equal to x, that 1 that's in the exponent that we don't write is going to come to the front. And we're going to subtract the exponent by 1, which is going to leave us 1 times x to the 0. Now x to the 0 is equal to 1, and 1 times 1 is 1. So the derivative of just the variable x is 1. If we go ahead and look at the f of x is equal to 3, so some function is just equal to some constant. That means we're going to go ahead and remember that 3 is multiplied by x to the 0 power. X to the 0 power is 1. We don't write that, but that's what's going on here. And what's going to happen is that 0 is going to come out to the front, be multiplied by the 3, the x, and we're going to go ahead and subtract 1 from the exponent, but 0 times anything is 0. So basically what's going to happen here is the derivative of any constant is going to be 0. So when we go ahead and take the derivative of a polynomial, that constant part of it, that constant part of the function, is going to become 0 and just disappear. All right, let's go ahead and look at another example. So here we have 4x. F of x is equal to 1 over x, and so that's equal to x to the negative first power. So we're going to go ahead and follow the same rules. So our derivative is going to be our negative exponent pulled to the front, and then we're going to go ahead and take our negative 1 and minus 1. So that negative 1 is going to be in the front, and our exponent is now going to be negative 2. And if we go ahead and simplify it to a fraction, we have the negative 1 over x squared. All right. If we have something like f of x is equal to 1 over x squared, that is equal to x to the negative 2 power. We're going to go ahead, take the derivative of that. So that means the exponent pulls to the front, and we subtract 1 from our exponent. So we're going to end up with negative 2 times x to the negative third power. And if we go ahead and make our exponent positive, we end up with negative 2 over x cubed. One final example of this, if we go ahead and have f of x is equal to the square root of x. Okay, well, the square root of x is the same thing as saying x to the negative 1/2 power. So I have the derivative of x is equal to 1/2, because the exponent pulls to the front, of x minus x to the 1/2 minus 1, which means we're going to have 1/2 times x And when we subtract 1 from the exponent 1/2, we end up with negative 1/2. All right. And so we're going to have the fraction 1/2, which is where the 1/2 comes from here. And we want to make our exponent positive so that x is going to go into the denominator. And because x is to the 1/2 power, it's going to become the square root of x. Right now, besides the power rule, what other rules are really helpful to us? So the first rule that's really helpful to us is when we want to take the derivative of two functions, so whether they are plus or minus. So if we want to take the derivative of f of x plus or minus g of x, it doesn't matter whether it's plus or it's minus. We can go ahead and take the derivative separately. So we could say that this is equal to the derivative of the first function plus or minus the derivative of the second function. So basically, we could go ahead for any polynomial, we could take the derivative of each term one at a time as we go along. Another thing that's really helpful is we have this thing called the constant multiple rule. That means if we have some function f of x multiplied by a constant, that we can go ahead, take the constant out of it, and take just derivative of just the function. So example for this, if we go ahead and we have f of x is equal to 3x squared, that means this 3 is not really a part of all of this. So really we're just taking the derivative of x squared. And when we go ahead and take the derivative of x squared, we end up with 2x by our power rule. And we're going to multiply it by the 3, the constant that we didn't take advantage of. And we end up multiplying those two things together and getting 6x. So here we're using both the power and constant multiple rules in order to go ahead and get this derivative, right? And sometimes many times, almost all the time, we use more than one rule at any one time. So let's go ahead and look at a couple derivative examples so we can get a feel for this. All right. So here I want to go ahead and compute the derivative. So our derivative is a polynomial function. F of x is equal to 12x cubed minus 8x squared plus 7x minus 5. And because these are all plus or minus, we can go ahead and use our sum and difference rule and take the derivative of each piece separately. So if I go ahead and take the derivative of each piece separately, if the derivative of x is equal to 12 times 3x squared, which is the derivative of x cubed, minus 8 times the derivative of x squared, which is 2x, plus 7 times the derivative of x, which is just 1, and then minus 0 because the derivative of any constant is equal to 0. And we end up with 36x squared minus 16x plus 7. Right, so let's make sure we go ahead and follow up these rules. So the derivative of any constant times x is just the constant. So anytime you have a constant times x, like 3x, it's going to become just 3. And another example is if we have f of x is equal to 90x, then the derivative is just 90 because x disappears in that sort of format. And anytime we take the derivative of any constant, it's always going to be 0. And therefore, it just ends up being eliminated from our polynomial function. Right, and let's go ahead and look at one more here. So if we want to go ahead and compute the derivative of 3x to the fourth minus 6x cubed plus x squared divided by 8 plus 5, we're going to go ahead and use both our power rule and our constant rule in many cases here. So for the first term, 3x to the fourth, I'm going to keep my 3, that's my constant, and I'm going to take the derivative of my x function by the power rule, which is going to be 4 times x to the cube, because remember 4 is subtracted by 1. I'm going to go ahead for the second term. So the second term has a 6, that's a constant. And the derivative of x cubed, remember we bring the 3 to the front, subtract 1 from the exponent, we end up with 3x squared. And then we have x squared divided by 8. You could do a couple different things here. You could consider the 1 divided by 8 as a constant. But that's what's really going on here. And then the derivative of x squared is just 2x, which is how we go ahead and get the 2x divided by 8. And then the 5 is a constant, so we compute the derivative. Any constant ends up becoming 0. So we end up with 12x to the third power minus 18x squared. And when we simplify the 2x divided by 8, we end up with x to the fourth.